I'm a neuroscientist here at Northwestern. And I'm going to talk to you about sensation. Now, you all know about the five senses, but I'm going to tell you about a hidden sixth sense that you all have. And if you'll indulge me, I'll also show you that hidden sixth sense. So, would you please take your index fingers and put them way out in front of you. And now close your eyes, and then touch your nose. Great, open your eyes. So it seems like everybody was pretty successful. If you tried this and you were successful, you probably thought that was pretty easy, right? But why was this so easy? Well, and how did you know where your finger was and where your nose was, and how were you able to bring the two together without even thinking about it? Well, the answer is this sixth sense. It's called proprioception. This proprioception is the sense of body. It basically tells you where your body is and what it's doing at all times. And the easiest way I can tell you about how important this sense is to show you what happens when you lose it. This is Charles. He's about to try and stand up. But he's lost his sense of proprioception due to this rare disease. He, believe it or not, can actually control all of his muscles voluntarily. But he's lost this feedback that he gets from his body. We need our proprioception for everything we do in our daily lives. So how does this sense work? Let's say you're reaching for a cookie. When you reach for that cookie, there are these sensors in your muscles that pick up the information about what your body is doing, what your muscles are doing, like how much the muscles are stretching or how much force they're outputting, and it converts that into this electrical signal. It then sends that electrical signal up the spinal cord and into the brain, in particular this area called S1. And from there, that signal goes sort of all over the brain to help you perceive your body and help you make movements, like reach for cookies. But what the brain does in this case is not trivial. For example, when you're reaching for that cookie, you're laser focused on what your hand is doing and where the cookie is and how to get that cookie into your hand and into your mouth eventually. What you're not thinking about is what your muscles are doing, how much your biceps is stretching or how much force you're putting on your shoulder. So obviously the brain actually abstracts out a lot of this information that you don't need and only gives you the information that's relevant for what you're doing. This question of what the brain does is what my research is about. But in my research, it's a little bit hard to measure precisely the electrical signals that are in the human brain. So what we do is we use monkeys. And what we have these monkeys do is we have them play these video games where they have this joystick and they're moving it around in front of them to reach to different targets. And while they're playing these games, we're recording from this area of the brain called S1. And when we're recording from these neurons in this area of the brain, the neurons look a little bit like this. They fire these little electrical pops. And as neuroscientists, we don't just like looking at these electrical pops, we also like listening to them. So when a neuron is firing, what you'll hear when you listen to these is this crackling noise as the neuron fires. And I'm about to play you a clip of a monkey doing a task in our lab while we're listening to a neuron. And I should warn you, it's going to sound a little bit like static, like the video is low quality, but that static is actually that crackling noise that I'm talking about. And I want you to listen for specifically when that crackling noise gets more intense and less intense and what the monkey is doing while that happens. So once we have this experimental setup, there are a lot of different questions that we can ask about what this area of the brain does. For example, you might have noticed in this video that that crackling noise grew more intense as the monkey was reaching away from his body. That neuron fired a lot more when he was reaching away. We call this feature a preferred direction, where the neuron likes it when the monkey's moving away from his body. A lot of neurons that we record from in this area have this feature, For example, in this figure here, you can see that as the monkey's moving along this black trace, this blue neuron fires mostly when he's moving towards his body, and this red neuron fires mostly when he's moving away from the body. And when we record from a lot of these neurons simultaneously, we see that these neurons have a variety of preferred directions all over this circle. So what can we do with this information now that we have it? Well, there are a lot of people who have lost their proprioception for one reason or another, either from that rare disease that Charles had at the beginning of the talk, or something more common, like spinal cord injury or amputation. Either way, they've lost that sense of feedback that they get from the body. So one thing that we might be able to do is bring back that sensation, at least partially, to those people. So one thing that our lab did a little while ago was we tried to do this. We took a couple neurons that had similar preferred directions, and we, instead of recording from them, we electrically stimulated them. And when we did this, we found that this monkey actually felt a bump in the direction that we chose. As we learn a little bit more about this area and what it does in terms of how it represents what the body is doing, then we can start to tailor this electrical stimulation to better approximate the natural sensation that you'd feel. And as we start to learn more about proprioception as a whole, then maybe we can return that sixth sense to the people who have lost it. Thanks.